Okay, students, in this video we are looking to solve triangles that are not right triangles. And for that we are going to utilize the law of sines. So let's say we have a triangle with two given angles and only one given side, such as this one here. Well, we can't use sine, cosine, or tangent. At least we can't use the ratios of those three because it's not a right triangle. So this is when we have to implement or use the law of sines. And the law of sines is basically just a ratio. So for example, the law of sines, this is what it looks like. It's sine of angle A over its opposite side, which is side A, is equal to sine of angle B over its opposite side. And we can also set this equal to sine of angle C over side C. So in reality, all we have here, guys, is just a ratio. And as long as we can set up a ratio with three of the four given measures, then we can find the fourth one. Let me show you what I mean by that. So in this triangle here, I have angle 68 and I have its opposite side. So I can say, well, I have sine of 68 degrees over its opposite side, which is 5. And that's equal to sine of angle 50 degrees over its opposite side, which in this case it's x. So I have 3 of the 4 measures given in this proportion, so I can solve for the third one. How do I do that? I cross multiply. So x times sine of 68 degrees is equal to 5 times sine of 50 degrees. And to get x by itself, all I have to do is divide everything by sine of 68 degrees on both sides. Sine of 68 degrees. And when I do this, if you plug this in your calculator, 5 times sine of 50 divided by sine of 68 degrees, we get that x is approximately 4.13. So we have the missing side, or at least x. X is equal to 4.13. Now, could I find this missing side over here? Let's call this y. And the answer is yes. I would have to set up another proportion. So I could do the same thing. I could do sine of 68 degrees over its opposite side, which is still 5, is equal to, so notice that I'm looking for y, so I need to find out what its opposite angle is. What is that angle? So if I do 50 plus 68, that's going to be 118 degrees. Subtract that from 180, and I get 62 degrees. So I can do sine of 62 degrees over y. And again, we do the same thing. We cross multiply. We get y times sine of 68 degrees is equal to 5 times sine of 62 degrees. And again, to get y by itself, all I have to do is divide everything by sine of 68 degrees on both sides. And when I do that, I get that y is equal to, well, let's plug it in, 5 times sine 62 degrees divided by sine of 68. And our answer is about 4.76. 4.76. All right. Let me get my pen and write that down here. All right. Right here. 4.76. All right. And we can say that we have solved the entire triangle using the law of sine. Okay, I hope that makes sense. There are a couple other things that we need to look at. For example, let's clear this really quick and start a new one. So there are a couple other scenarios, and this is in your homework problems, and it looks something like this. So sometimes you will be asked to determine whether the lengths given are sides that make a triangle or not. So a couple things. First, we need to consider the actual angle. If the angle is acute, and so we're going to consider this right here. If the angle A is acute, and the side that it's opposite to angle A, so if angle A is acute, let's say 50 degrees, and the opposite side, A, is less than less than the actual height, then we can say we cannot have a triangle. There's no solution. If this angle A is acute and the opposite side is the same as the height, then we can say there's only one triangle, and that's going to be a right triangle. If the opposite side of angle A is more than the height but less than this side over here, then we can say there are two possible triangles. One that looks like this, and one that looks like this. So we would have to consider solving for both of them. If the angle is acute and the opposite side is more than B, then we have one triangle. Now, we can also apply the same rule to when the angle is not acute, when it's obtuse, or when it's right. If the side opposite to that angle is less than B, then we say there's no triangle. If the opposite side is more than B, we say there's one triangle. So let's look at one problem where we can look at these possible scenarios. And let me pull one up really quick. Bear with me. So let's say that we have this scenario right here. Let's say angle A is 30 degrees. Angle A is 30 degrees. All right, so angle A is 30 degrees. Side A is 1 and B is 4. Okay, so this is what we have. Let's draw this triangle. So here we have 30 degrees. That's going to be angle A. The opposite side is going to be 1, and this side over here is going to be 4. All right, so let's determine what the possibility could be. Well, the first thing I need to find out is what the height is. All right, remember that's just a line straight down to the base, forming a right triangle. I need to know what this height is. Well, notice this is a right triangle now. So this is a right triangle here. All right, so keep that in mind, that's a right triangle. So I can do sine of 30 equals h over 4. I want to know what h is, so simply multiply both sides by 4. And remember that sine of 30, guys? Sine of 30 is just a half. It's 0.5. Times 4, I get 2. So h is 2. All right, h is 2. All right, so let's see which of these up here is meets this this criteria. So it's acute, all right, and notice this side is less than h. That means we have no triangle. Side 1 is not long enough to make to form a triangle. So we're going to say there's no solution. There's no solution. All right, let's look at another one where there is a solution. So the next one, I believe, has 2 solutions. All right, let's just clear this really quick. Let's clear all this. All right. All right, here we go. We have another possibility. So let's say the angle given of a possible triangle is 50 degrees. All right, so this is going to be 50 degrees. That's going to be A right here. The opposite side is 34, and this side over here is 40. So how many solutions does it have? Or how many triangles can we make with this? Well, first I need to find out what this height is. That's going to be the biggest thing. What is this height? Again, let's do a ratio. Sine 50 degrees equals h over 40. Multiply both sides by 40. So 40 times sine of 50 degrees is equal to 30. Let's zoom in a little bit. I'm not sure what happened to this. All right, let's just bear with me 1 second. Some issues here. All right, let's just keep going, guys. So we're almost there. So h is 30. H is 30. So h is about 30.64. All right. So here we have this side is more than 40, more than h, but less than b. That means we have this possibility. We have 2 triangles. Let me see if I can make this a little bit bigger. It's a little hard to see. All right. Let's make this a little bigger. There we go. Let's erase this. All right. So, if you notice this side here, right, this side here is A, and it's more than H, but less than 40. So that means we have two possible triangles. We have that one, and we have this one. So this is going to be, again, this is angle A, it's 50 degrees. This is angle A, it's 50 degrees. This is side 34. This is side 40, side 40, and this is 34. So let's use the law of sines to find the missing angles. So let's say this is angle B. So we're going to do sine of 50 degrees over its opposite side, which is 34, equals sine of angle B over side of 40. Multiply both sides. If I multiply both sides here, just across, you get 40 times sine of 50 degrees is equal to sine of B times 34. And to get sine of B by itself, simply divide both sides by 34. Divide by 34. So here we go. We got 40 times sine of 50 divided by 34. And we actually get a decimal. But do not be alarmed. That's actually normal because we need to find out what angle B is. All right, so just bear with me, guys. My clicker is not working. All right, here we go. So this over here became 0.017. So 0.0157 equals sine of angle B. Well, how do we get angle B by itself? We need to use the sine inverse on both sides. So sine inverse, and we get that angle right there is going to be approximately about 36, give or take. All right, let me just check that one more time. It's actually 64 degrees, guys. 64 degrees. All right, so B is about 64 degrees. That means that this angle is 64 degrees. All right, here's how we find this angle over here, angle B. So whatever this angle is, 64, subtract that from 180, and we get this angle, 116. Well, what's this angle up here? Well, 50 plus 64, it's going to be 114. Subtract that from 180, and we get 66 degrees. How about this angle over here? Well, 116 plus 50 is 166, which means this angle here is 14 degrees. And how do we find this third side? Let's call this side C. We do, again, the law of sines. So sine of 50 degrees over 34 is equal to sine of 66. Now that we have the angle, over its opposite side, cross multiply to find C. And this other side, it's the same idea. Sine of 50 degrees over 34 is equal to sine of 14 degrees. 14 degrees. Let me move this slightly to the right. sine of 14 over side C. All right, so again, cross multiply, and you will get your answer, whatever that is. It's going to be a decimal for both of them. So this is an example of a case where there are two possible triangles. All right, I hope this makes sense. Please let me know if you have any questions.